All right, and welcome to Module 2. This is the first day of Module 2. This should be Lesson L10, and we're going to be completing pages 1 through 5 in your packet. One thing I want you to note is that the first couple of pages, this is actually an exploratory activity, so you have to read what it says and work through it. So what you should see on the top of your paper is plot ABC with the coordinates -9, 8, so this would be A. B is at -4, up 4, okay? And then C is at -1 and up 6. So you're going to actually, for each of the next 3 pages, these are the coordinates you're going to start with, and you're going to determine what happens after you do different transformations. So the different transformations we're going to talk about today are reflection, translate, and rotate. Okay? So if you read through the directions very carefully, yes, you do have to read each of the directions, you should be able to figure out what to do with the coordinates. For example, on the first page, you're going to take each of these coordinates and you're going to apply the rule x plus 5, y minus 7. So basically what that means is you're going to add 5 to each of the x coordinates, and you're going to subtract 7 to each of the y coordinates, and then see where your shape ends up when you have the new coordinates. The second rule on the second page for number 2, you're going to apply the rule x comma negative y. So this is number 2. You're going to look at these same coordinates. The x is going to stay the same, and the y is going to change. So for the first coordinate, A prime will be at -9, so that's the x staying the same, and the y becomes -8. For number 3, the rule is -y comma x. So you're literally going to take these coordinates and flip-flop them. So the 8's going to come first, then the -9, and the y is going to become opposite of what it was originally. So the original 8 was positive. This tells you to make it negative. And then graph those points and see where you end up. So go ahead and pause the video at this time and finish numbers 1, 2, and 3. So welcome back. Hopefully you got all that taken care of. When I think of transformations, I think of transformers. And what that makes me think of is how there's a series of rotations, reflections, and translations that make like Optimus Prime go from being robot form to the truck that he is, okay? And that also makes me think of the word prime. And so a transformation is an operation that maps or moves a figure to a new position. Okay, so the original shape, we call that the pre-image. And then when you see this little prime symbol, that little symbol there is called the prime symbol. That indicates the image after a transformation has occurred. And the different transformations we're going to talk about are reflections, translations, rotations, point reflections, and dilations. Those are the main 4. So once again, there are 4 kinds of transformations. One is a reflection, and then you've got a translation, a rotation, and lastly, a dilation. Okay. So when you looked at today, when you looked at your shapes, number 1 was a translation. And this is what a rule looks like for a translation. So this was a translation, and it was like number 1 in your packet. Okay. Number 2 in your packet, that was a reflection. And what you should notice is that your image flipped. Okay. And then the number 3 was a rotation. and this was the rule. And what you'll notice is that the coordinates flip-flop, and one of them became negative. And this one we're going to talk about later. This is a dilation. Okay. So once again, if you didn't do the geometry introduction and exploration, you're going to want to pause for a second and go ahead and get that done. All right, today we're just going to focus on reflections. And so a reflection is a transformation in which a figure is reflected over a line. Okay, the point of the pre-image is the same distance from the line of reflection, and thus it's a perpendicular bisector. So there will be a line of symmetry, and we're going to look at this. So if I were to look at this swan, I would see that the line of symmetry in this picture is right here. And that would be like a reflection across the x-axis. And what I set up here, is that the point of the pre-image is the same distance from the line of reflection as the point of the image. So if I looked, say, at the swan's eyeball, and I reflected it down here, I would know that it's going to be the same distance across the line of reflection, and it's going to be a perpendicular bisector, so they're going to cross at a 90-degree angle. That's an x-axis. If I looked at this lady, I would cut her down the middle, kind of gross, but that would be a y-axis. And again, if I look, say, at the point on her knee, and I would see that this point on her knee and this point on her knee are exactly the same distance from the line of reflection, so these are congruent, and they make a 90-degree angle. Okay. This does not have a line of reflection, but this image actually has two. You could actually cut it this way or this way to see a line of reflection. So remember that when you're actually practicing this. So let's go ahead and look at number 1. This should be on page 4. There it is. Okay, so we're going to reflect over the y-axis. This is where you want to start taking notes, so you want to know what the rule is. So one thing we could do is just use our line. This is y-axis is going to be my line of reflection, and I know that everything's going to be exactly the same distance apart, and it's going to reflect across. So if S is here, S prime is going to be here because it's 5 away, 5 away. If R is here, R prime is going to be here. And T, because it's on the line of reflection, is going to stay exactly where it is. Okay, so my new image is right here. But let's write a rule for this. What happened to my coordinates? Well, let's look. S is currently at -5, 5. S prime is at 5, 5. So what you can notice is that the coordinates stayed the same. So you have an x and a y coordinate, but what happened was the x coordinate was negative and now it went positive. So that makes us put a little negative sign in front. And you'll notice the same thing happens with r. So r was at -5, 2, and r prime you can see is at +5, 2. So our rule checks out. Anytime you reflect over the y-axis, the rule you follow is -x, y. All right, let's look at a reflection across the x-axis. So if we reflect across the x-axis, our reflection is going to go up or down. Okay? So if the point is above the line, it's going to reflect down. So it'll be like right here. If it's below the line, it's going to reflect up. This. And you should notice your shape is exactly the same. It has just flipped over. So let's notice what happens to these coordinates. So let's look at D. D is currently at 0, -3. And if you look at D prime, you'll notice it goes from 0 to +3. So what we'll notice is that our x and y coordinates are the same. However, this time instead of the x coordinate changing, the y coordinate changes. Anytime you reflect across the y-axis, the x-axis, excuse me, this is the rule you follow. The x stays the same, and the y changes. Another example. This time we're going to reflect across the y equals x line. And this line is actually this diagonal right here. It cuts the grid diagonally like this. This is the y equals x line. This rule's a little bit different. It's a little funky. So basically, for this, you just flip-flop the coordinates. So what you'll notice is it's going to be exactly the same distance. So S prime is going to be here because it's got to cut at a 90-degree angle with the line of reflection. And so this one's going to end up, I don't really know, I think here. And you'll notice that it kind of looks like this when it reflects. So let's look at our coordinates and see if, in fact, they flip-flop position. So let's look at t. T is at 0, 5, and you'll see that t prime is at 5, 0. So yes, in fact, it did happen. U is at 0, 2, and U prime, you'll see, is at 2, 0. So again, you'll notice that the coordinates are flip-flopping positions. S was at 3, 1, and S prime is now at 1. Okay, so those are the three main reflections, but sometimes you're going to reflect across a specific line. So what's different about this is that if you're going to reflect across the line x equals 3, the first thing you have to do is find where x equals 3, which is right here. And actually, it's not going to be a horizontal line, because that's just the x-axis. It's actually going to be a vertical line. And then you just have to use your rule that each point is going to reflect evenly and directly across at a 90-degree angle from the line of reflection. There is no rule to memorize for these. You just do it. And if y equals 2, this is going to be a horizontal line where y equals 2. So go ahead and draw your horizontal line. And this time your shapes are going to flip up or down. So that's that. All right, so those were some examples on your homework. What you are going to be responsible to do is there is a Desmos activity. So you're going to go to student.desmos.com. And if you're in first block, you're going to type in this code. Second block types in this code. Fourth block, this code. And you also have to do the practice problems 2 through 12. Good luck. Please remember, if you have a question, you may re-watch the video at any time to take the notes.